Well, good morning, everyone. I know it's a bit hard task. Wake up early in the morning to join the conference after such nice dinner yesterday night. But I'm glad many of you are still here. Okay, very good. Probably even here something went wrong. I don't know what's happened. Anyway, we had to start again. The very last day of this conference is a very interesting day, rich of interesting communication, and we are going to start with the plenary speech. Okay, it's a pleasure and an honor for me to introduce Professor Michael Sweet. Mike is a brilliant, enthusiastic researcher. His curiosity leads him to always be ready for new challenges and collaboration. I met him the first time in 2013 at a small island, Vavaro, at the Maldives. And from that, we started to collaborate each other. And to tell the truth, if we are here today, actually is partly his fault, because he basically make the trade union between me, Carlo, and the ECRS, and actually lead the base for this symposium here in Naples. Well, Mike is a multi-hour winning British scientist and educator, and probably work in one of the strangest places for a tropical marine biologist, the birthplace of the Industrial Revolution, a small town right in the center of the UK known as Derby. He tried, via various routes, to repair the damage caused by this revolution and provide tools and training to communities around the world. He's published over 150 papers in a decade, and also a textbook, an introduction to molecular ecology, which is found in libraries around the world. He's co-created also a charity which tackled the issue around the ghost fishing and charter entanglement, the Olive Ridley Project, if I will pronounce, and remains as a trustee. He was an officer for ECRS, you know, and RC UK, helping organize and run various conferences, and still sit on the board of the advisor for Hope, a Tanzanian charity working with local community to restore reefs in the country. He's a fellow for ECRS and the Royal Society. He's also a red list assessor for the IUCN, lead for the coral reef chapter of the IUCN World Ocean Assessment, and presenter at the COPs, all with the aim of trying to push into the murky world of politics. Finally, he's a fan of a circular economy, making business pay for their carbon footprint along with tackling its home. So, Mike, please take the floor.
Thank you very much. Thank you first for waking up and turning up. And thank you very much to Massimo and Carlo. It's a great honor to be invited here, and I think you'll agree that they've done an amazing job. So hopefully you recognize that and congratulate that to them face to face throughout the rest of the day. So apologies if this is going to be a bit of a rubbish talk, but it will hopefully all become clear in the not too distant future of why there is a pile of rubbish right in front of you. So as Massimo said, I'm a big fan of circular economy, and so I'm going to highlight hopefully to you guys how we can make businesses pay, and that business isn't always the evil elephant in the room, and we'll see if I persuade you on that. And also, I like to give interactive lessons, so maybe you'll have to do something as well. So it doesn't matter what graph we use, but it's clear 2023 was bad, and 2024 is looking even worse. And obviously, this is impacting our corals quite significantly. So in 1998, we all know we had our first declared mass bleaching on record, and that impacted 20% of reefs. In 2010, it was thought to impact about 35% of reefs. In 2014 to 17, NOAA said it was 66% of reefs infected. 2024, we're now at 72, or I think it was even 76 when I just last double-checked this. And then by 2030, there's estimates that by 90% of reefs will actually become functionally extinct. So that's obviously modeled, but this gives us a potential timeline to start thinking about that we really, really, really need to act. I'm sure most of you know that, but how many of you are actually putting your money where your mouth is, so to speak? And we're going to explore that as we move forward. So I use this timeline for myself and for my research to give us a 6-year time period to do something about corals. That's not climate change yet, we'll talk about that in a bit, but for corals themselves specifically and coral reefs in general. So obviously, to give coral reefs a chance, we really need to reduce our carbon footprint. No one's denying that. And hopefully that message comes quite clear and across to everybody. We've all seen things like this in UN reports, and our magical number of trying to keep the world below or at 1.5 to save the majority of reefs is what we target. Agree? Come on, you have to interact. Agree? Yes. Okay, this is our magic number. Fantastic. If we go to 2.5, then this is what we saw 3 million years ago. So this is already where we start thinking, okay, we might need to start thinking about our change and about our perspectives and about what we want out of our world and what is realistic. So this is where shifting baselines come in. I'm only just going to touch on very few points, and the idea is that hopefully if you're not necessarily aware, or you are aware but there's more detail, you'll delve into those afterwards. But obviously this was a graph which was produced in 2019, and it resonates quite nicely with me. It sort of shows where we're moving, and we see it with our very own eyes, and obviously the desired long-term outlook. But is that desired long-term outlook even a reality? Can we save reefs? Can we save corals? These are questions that we need to ask ourselves every day, and it's implemented in the actions we have as well. So if we hit the 1.5, we can see that our reefs are going to be very different than we still see some beautiful reefs today, but they're getting rarer and rarer, unfortunately. And it's more and more likely that the structures of reefs are going to be further down that scale. So where do we set our objectives when we're thinking about restoration and conservation? And it's an open-ended question, but it's definitely something that you need to think about. And if you constantly try and keep going back to the top of this graph, then maybe you're setting yourself up for huge amounts of disappointment and depression, which is sad. So this is the interactive bit, just to make sure that you're all awake. So the Guardian, newspaper, so whether we could trust the results or not is a different story, interviewed all the IPCC climate experts on what they thought we were going to hit in the not too distant future. So I would like you to all stand up, please, if you will accommodate. Thank you very much. I appreciate this. You don't have to stand up if you don't want to, but it's very nice of you to stand up. Thank you very much. I might make you just stand up and give me a round of applause right at the end as well, so we have a standing ovation, but that'll be up to you guys. So what I want you to do now is sit down if you really believe and you think we can get below 1.5 degrees. Have a look around. No one's sitting down. What about that magic 1.5 degrees? Who's optimistic? Come on, there's got to be one optimistic person in the room. No? Okay, good. We're all scientists and very pessimistic. What about 2 degrees? Oh, we've got a couple of sit-downs over there. Good for you. 2.5. Oh, that seems like a good number. That's maybe a third, possibly getting up to a half. 3. Oh, Gert's being very grumpy. 3.5. Oh, he's going to stay. 4. Oh, you're going to sit down on 4? Oh, okay, is that everybody? Right. So that gives you a bit of an understanding of what you guys, as trained scientists, the best of the best of our coral community, or the European side, and a few of those pesky Aussies and Americans and others, but they crept in anyway. But what did the IPC say? So each one of these squares is one answer, and in a similar sort of connotation, it was likely what you showed as well, which I find quite interesting. And I was sort of hoping that would be the case, but I thought some of you might be a bit more optimistic. But 77% of climate scientists from the IPC said that we would expect a rise of at least 2.5 degrees. So straight away, that means we have to start thinking about what our reefs are going to look like, and therefore what is realistically an opportunity to actually preserve, conserve, protect, restore, whatever you want to utilize. So that's one thing to think about. And then obviously the other thing is still having that benchmark. So I don't want you to leave in a downer or pessimistic. I'm going to hopefully show you some ways that this can be maybe flipped around a little bit. So if we want to get to that 1.5 benchmark, this is what it's looking like as far as temperature. So it looks bleak, whichever way you look at it and whichever confidence interval you take, it's certainly not looking very good. And what was clear is that when you act is very, very important. So if we had acted earlier, in 1998, for example, or 2010, and I would say we, as in the global community, then we would have had to react less, and it would have been a less steep curve and a less amount of disruption for the general public, and possibly it would have been taken up a little bit more. The longer we leave it, and we're still not really acting, as you'll see in a bit, it's going to be a more steeper curve to try and reduce that carbon footprint, and in fact sequester carbon, which is apparent what we really need to do. So if we stick to our current policies, this is the darker orange on this graph, that we're going to really fail to bring carbon emissions to zero, and this is likely to really push to 2.5 degrees. They say about 2100, but I think that is optimistic. I think it's going to be a lot sooner. I tried to find, hopefully you guys all understand about the sort of lag period associated with our carbon footprint. If we stopped our carbon footprint overnight, there's a period of years where you would carry on seeing change. And that's very difficult from a general public point of view to tell them this, because if you tell them you can't drive your cars or you can't fly around, they want to see an immediate effect. They want to see something come true. And it's the same for policy. So politicians want to see something happen in their term, usually a 4-year period or something like that. And I appreciate that, and I understand that, and we try and work with the general public and with politicians to come to an understanding about who it's going to affect in the future. Again, it's preaching to the converted, hopefully, but I don't necessarily think everybody is properly converted, hence why I thought I'd pitch this today. So if we stick with that, it's not going to look good. If we wait till 2050, a lot of people are saying 30 by 2030, but then realistically, I'm seeing a lot of promises coming in later. So there's a lot of very interesting policies which come out at places like the COPs, about no bottom trawling and things like that. Really relatively easy things that can be implemented, again, relatively overnight. But they say we're going to do it by 2030 and we're going to do it by 2050. And what really gets me is why are we not doing it now? Because it's going to be too late. So if we wait till 2050, this is just for our carbon emissions, we'll almost certainly need to be extracting large amounts of carbon from the atmosphere to even just limit it to 2, even if we go over that in the first instance. But if we want to keep it to 1.5, our magical number, then models indicate that we need a huge amount of carbon to be removed pretty much from now onwards, yesterday, last year, if not better. But as far as I'm aware, even though there's some pictures out there which show time travelers running around, I don't think we're there yet. Oh, click, come on. There we go. So what are the roadblocks? Well, we're investing in clean energy. This is great. I pulled this graph off. This highlights the renewable power, nuclear, energy efficiency, grids and storage, low carbon fuels, electric vehicles. It's great. It's increasing over the years. But it's increasing slowly, and this is a problem. But the reason it's increasing is because someone's making money out of it. Okay? So this is the first sort of stage where business becomes important. If no one was making money out of it, it wouldn't be happening at all. So we have to not be afraid of business, in this instance, of making money, but as long as it's pushed into the right direction. And is it being pushed into the right direction? Well, the fuel companies, good old fuel companies. This is Shell, net zero strategy to power the green industrial revolution. Yay, great. This is Shell again, our approach to climate change and the energy transition. These were all, you'll notice on the tags, they're 2021. 2021 was a good year, apparently, for marketing. BP ventures to invest 200 million dozen green energy startups. This is Chevron's commitment to carbon reduction through the science-based targets. And this is ExxonMobil, why we're investing 15 billion in low-carbon future. It's good? It's promising. It showed a willingness, a value to it, and if you dig into these reports, quite often they're financial reports as well, it highlights the financial gain to these companies to move in this direction, otherwise they risk getting left behind. So there was a financial shift to this, but this is true greenwashing in my opinion. And I recently have been involved in proper marketing, the dirty word of global marketing, and you'll see that at the end of this talk. But this is what's happening now. So Shell revises the climate targets as it plans to keep the gas business growing. It's almost predictable. Shell pledges to invest in new oil and gas production for years to come. BP to stick with oil and gas for decades, says the CEO of BP itself. Chevron has a new $2 billion offshore deal with Equatorial Guinea. ExxonMobil sticking with oil as some rivals look to a greener future. And this is where we're going. So it's very easy to say one thing, and then it's very easy to, and it's very difficult to actually do it. And why am I mentioning this now? Because it's pretty obvious. Because when I speak to people, the general public, but also you guys in the room, I hear it's the 1% of the country, of the world who are generating this problem. It's the developing country who is the big issue and the big pollutants. And we can't do anything about it. Who thinks we can't do anything about it? Oh, I might end my talk now then if you're all converted. So we can do something about it. Or you've stopped talking. Huh? We should. Yeah, we definitely should do something about it. So what I think about it, so my nana was born in 1926. This is a picture of my nana holding my mum. This is my mum in 1962, not holding me, unfortunately, but holding my son. This is me holding a sea cucumber. Didn't touch it. And this is my son. So whoever you are and whatever your family is, NASA are doing this now so you can actually plug in your own data. I think I thought I had the source on it. So you can actually plug in your family's dates and see how it's going to be impacting them onto this nominal graph. And you can see it's looking very, very bleak. So even though I do feel depressed quite regularly, I put my hand up on that, and I do feel lost, and I do feel that no matter what I do, it doesn't really help, I'm not going to stop fighting. So I'm going to do everything I can to make a difference. But that's the key. I want everything I do to actually make a bit of a difference. And it could be a really small drop in the ocean, or hopefully it could be something which inspires and pushes forward many for generations to come. Click, click, click. Come on. Right, so why have we got rubbish here? We all know we need to refuse, reduce, reuse, repair, recycle. This should be our mantra. We should be singing this from the rooftops. We should be doing it. If you look inside yourself, how many of you are really doing this? Honestly? How many of you have changed your way of life significantly? How many of you really, really think about attending wonderful conferences like this, about your carbon footprint? How many of you just rely on the great strategies which are undertaken to offset that carbon footprint and go, yep, that's okay, that's done, that's my job done, thank you very much, and that is amazing. But then we see this rubbish. So I've been to a couple of COPs now, and I found this very, very interesting. So this is extracted materials in billion tons a year. And if we have this linear economy, which we currently really do, then our general waste, and this is a major part of our carbon footprint, is just increasing, 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 increasing. So between COP21 and COP26, when everybody talked about all the changes that need to happen, there was significant increase still of the waste. So over a trillion, half a trillion tons of virgin materials were consumed just between those time periods. And it's projected that by 2050, this is going to be a staggering 170 kilotons, which is pretty spectacular. So our take, make, waste economy consumes over 100 billion tons of materials a year and wastes over 90% of it. So this is what this example is here. This 3 bags is only a small proportion of our waste, the people who know what we're doing, and the people who we're trying to educate, from the one poster session last night, and I only bothered to bring about half that waste here. And so that sort of gives you a take. And this is an eco-friendly conference as well, and it's really put quite a lot of thought into that, but we still generate a significant amount of waste. Still generate a significant amount of plastic. So reports suggest that in the last 6 years, we've globally consumed over 70% of what we consumed in the entire century beforehand. So let that sit in. 75% in 6 years compared to 100 years before. We don't seem to have learnt our lesson very well, and this is what we're fighting against. Sounds very depressing at the moment, doesn't it? But while we sit around and wait for our planet to cool, which is what we want, what should we do about coral reefs? I hear coral scientists. I'm quite active on things like Twitter and stuff like that. X, sorry, Elon. And a lot of people say things like restoration are a waste of time, nature does it best, why are you bothering doing that? That's greenwashing itself. And I strongly disagree in those instances, and hopefully I'm going to highlight why we should give a shit. So Chris invited me on this paper a few years ago in 2021, and this was all about extending the natural adaptive capacity of coral hollow bounce, and it's all linked around nature-based solutions. So we all agree that nature does it best, yeah? Nature is amazing, nature is wonderful, that's why we're all biologists and scientists and geographers, and it's very, very special and super amazing. And some of the previous talks have highlighted that it's very complex and we don't understand enough about it, and so on and so forth. But when do we understand enough, and when are we going to act, are questions that I've been asking myself quite a lot. So we understand a fair chunk about the viral community, we understand about the prokaryotic community, we understand about the Symbididiaceae, we have a bit of a good picture on acclimation and epigenetic modification, and then adaptation. And this has all been built up on decades of research from many, many very talented folk. But the problem with nature is us. And when you get corals being separated far and far apart, it becomes problematic, and never the twain shall meet. And so you do actually really have to intervene. And it's sad that we're at that stage, but it's where we really are at. And if you want to argue that point with me, then feel free. I'm very happy to do that. But I'm going to focus the main part of this talk on two aspects. Sort of coral propagation and selective breeding, and then a bit on the prokaryotic community. But like I said, I'm only going to just touch on a few bits and not go in depth, because I wanted it to be quite general and far-reaching for everybody. So with coral propagation, this all started in a strange place in the UK, in London and in Derby, and where we induced the broadcast coral spawning of corals. So we closed, in a closed system with artificial water, we built it. So Jamie was based in the Horniman at the time. I actually earlier started doing my PhD with the Horniman, and then when I got a full-time position, convinced Jamie to convert this into a PhD to reach the wider community. And it was all obviously around things like seasonal temperature, solar irradiation, the photoperiod, the lunar cycle. And what you see in this picture is probably version 4, which started to be a commercial product that you could actually purchase. So I know many of you in the room have actually got this system now. And in 2020, in lockdown, we actually commercialized the science. What was also very important to start off with is this is an open access paper as well. So that is one of our ethos is to make sure that anybody can get hold of these systems where possible. And the commercialization side of things, I know it's a bad word, was developed for a variety of different reasons, and we'll highlight that as we move through. I'm alternating between buttons. But the power of this spawning system meant that you could flip it and spawn during the day, which was nice. And because we're British, we used to say we have a cup of tea when we spawn, and it was really pleasurable rather than staying up at night and waiting for that inevitable puff. And the second beauty is that you can induce multiple spawns each year. So I don't mean that you can induce multiple spawns from the same coral each year, or do I? But if you have multiple systems, you can, in theory, spawn corals throughout the entire year. So with Galaxia, which is what you just saw, giving you a nice firework display, this is just a little example of how it all worked. Come on, click, click, click. So we had our in-sync system. So when we first started doing this, we synced the systems to wherever we were acquiring those corals from in the first place. And so you just match the environmental parameters to wherever you get them from the reef. And lo and behold, at the same time, or usually a few days after, you get spawning. And this isn't just a one-off. I will show you how we've done it in multiple cases. If you have another system and you shift all those parameters, we tried to do it in separate parameters, and we figured out quite early on that because of that complex world, you need to shift the vast majority of those parameters. You can make them spawn 4 months later, and same, you can make them spawn 8 months after that. So you can do it year on year, you can do it month on month, and you can do it with multiple different species, which means straight away we've made something which happens usually once a year. That's not true. Quite often it happens, like in Maldives, it happens pretty much 11 months of the year as far as we're aware, the phenomenon of spawning. But in many instances, it's often 1 or 2 nights or once or twice a year. What we have also found is that you can actually induce the same coral to spawn multiple times a year, but the gametogenic cycle of most corals is actually about 8 months. sometimes late 11 months, and you can actually, if you do histology, you can actually see the eggs developing for over that 11-month period. So if you do push the same coral to spawn in multiple times, then what you'll actually do is exhaust the animal out, and she, he, it will die, but you'll generate a large amount of babies from that. So it's a strategy, if you wish, to sacrifice a large adult colony for thousands of babies, but it's not one we advise, but I know some people are thinking about those sort of rapid ways of ensuring genetic diversity. But what we have also started finding is that the same corals do actually spawn multiple times a year and don't exhaust themselves out. We don't have the answer to that, but it definitely happens in more instances than not, and so it's something that we're looking into quite nicely. There are some colleagues here from the King Abdullah University of Science and Technology, and this is actually where my journey with CSL all began. So the company we created was called the Coral Spawning Lab. But in 2019, Christian Volstra and Manuel Randa invited me to come to KAUST and have a workshop, and we talked to them about this ability to phase shift. And they said, we want that. And I said, okay. And I phoned up Jamie and said, how do we do this? And then we panicked and gathered together a team of people who could deliver. And what they wanted was that thing I had promised them, spawning all year round. And what they wanted to do was CRISPR-Cas9 gene editing, and what they were relying on was that one point of time every year to spawn corals. That's great, but that's costly from a time perspective. If something goes wrong, you're paying postdocs, technicians, PhDs to do this work, and if you could speed that process up, then you're going to speed science up as well as restoration. So we said, yep, we'll do it for you, no problem. Bit cocky, but we'll get it done. What staggered us was between 2022 and 2023, they got 95 spawning events. So we aimed for 12, and we did this in 3 major systems, and what they got was 95. We don't necessarily have the full explanation on that, but 30 yielded enough gametes for fertilization, and this work is continuing as we speak. So we hope that was pretty groundbreaking for Manuel and Max, and it's just the start of things to come. So our vision with the company was to enable and equip every practitioner, reef manager, and restorer with the capabilities to spawn coral in a controlled and reliable manner. The reason why we did it through a company is if I do it through my university, it would be very slow. I'm not afraid to put my hands up and say universities don't really work that well in that sort of context. So a business is generated to do things quick and hopefully do things well and hopefully ensure that quality is there. So to date, we've distributed 75 systems and spread out quite nicely around the world in various different locations. On top of that, we carry on showing that these products can work in various different ways. So again, we're just touching on a project which we conducted quite a few years ago, actually, but it just takes a chunk of time to get these papers out nowadays. And that's part of why I'm sharing quite a lot of unpublished data, is because we don't have that time to worry about things being done before us and stuff like that. So we need to change our own ethos. So this is all about assisted evolution, assisted gene flow. You will have heard quite a bit about that, I'm sure, about the concepts, about the theory, about the ethics. Should we be doing this? We don't tell you that you should do this. We just show you that it can be done. So in this experiment, we took 2 different species of coral, and sorry, Andrew and Tom, if those species are wrong, but we've already had that discussion. So we took what we call Acropora millipora and Acropora hyacinthus at the time from the Great Barrier Reef and from Singapore. So straight away, Tom's going there, completely different species. And the idea was that obviously in Singapore, they're more used to higher temperatures than in Australia, as you can see through this map, but they spawn at different times as well. So traditionally, the ones in Australia, they're spawning around November, and traditionally, the ones in Singapore are spawning around March, April. We synced them together in one system and made them spawn at the same time. So that meant that we could do that assisted evolution and assisted gene flow really easily, really quickly. And so we did crosses crosses between the species. So we had geographical crosses between Millipora and Millipora from Singapore and Hyacinthus and Hyacinthus. And then we also had hybrids as well, which is a great way of also adding some information to Tom and Andrew's work to highlight if those species are true species or subspecies or what have you. I'm not a taxonomist. And then we did some metabolomics, which I'm not going to get into, but we showed that the juveniles are more plastic in their nature to thermostress. So you can shift and change the thermoadaptability of the juveniles, and they seem to be much more malleable, if you will, for various different reasons, which we've looked into as well, than the adults themselves. So again, offering that various different ways of future-proofing your corals, dare I say the ugly word of supercoral. And then obviously the next stage, so if you crack coral spawning, which we argue has been done by and large, then the next stage is the bottleneck. So everybody has probably experienced some aspect of this. In fact, there was a talk, oh, no, sorry. Yeah, go back. There was a talk earlier which highlighted the issues around coralline algae, and we will tell you how we've tackled that as well. But you can see in this instance that CCA, which has always been heralded as being very important for coral settlement, is actually also something which overgrows the spat as well. And then on top of that, you've got red algae, filamentous algae, sedimentation, cyanobacteria, diatoms, ciliates. It's a whole battalion of things which don't want these corals to survive. And this is under natural circumstances as well. So what we did to tackle this, again, we used those nature-based solutions, and we looked towards urchins for this instance. So this, again, was a 2019 paper, so some of you will have probably seen it. And this was all around the idea of co-culturing to make microherbivores. So why we need microherbivores? Because if we use the adults, so these urchins are about this sort of size, these tuxedo urchins, they will graze over the coral looking for the algae, but they don't know what they're doing, and they just munch and bulldoze into the larvae as well. And so if you get the micro herbivores, the little baby urchins on the job, they do a very, very, very good job for you. So this, like I say, was a 2019 paper. We had 4 various different treatments which related to urchin densities in the wild, as far as we could tell. It was quite difficult to actually find that number. But the high grazing density was actually a true density found in Hawaii at that time, 75, which was the equivalent of 75 urchins per meter squared. And you can see on this graph here that survivorship increased significantly as urchin density increased. So that was the first result, which was really good. But then we also got, as you can see with the graph and the picture just below that, an increase in the coral spat diameter as well. So these were all taken at the same time. This is A is no graze, which is a bit of a dramatic control because there would be very unlikely to be nothing in a system to graze on anything. But B was the high grazing system, and you can see survivorship and growth was significant. But what was also quite exciting, or sort of a null result at the time, was the thing you could see on the right-hand side, where we got, as you increased urchin density, obviously the body size of the urchins decreased. And that's to be expected. You've got more urchins grazing on a limited supply of algae, and they're doing their job, so thank you very much, urchins. But what do we do with those urchins afterwards? And this made us start thinking about a few different things. And one option was we can keep them small, so we can be mean and evil and just keep them reduced in their growth form, and then you've got that microherbivory army to carry on doing their job for you. Or you can start thinking on a circular economic model where you can actually start to sell your urchins. So each of those urchins actually costs about £20 in the aquarium trade. So if you're producing hundreds of thousands of them, you can have a circular economic model based on your urchins. Or you can have a circular economic model based on these rare corals. So what we started doing, instead of focusing on acroporids, we started looking at some of the rarer species of coral. And some corals in the aquarium husbandry trade can go up for £300 per coral. There's even an acropora called the widowmaker, because it causes a lot of problems in marital life when one of the partners spends large amounts of money on said coral. This is the elegance coral, and this was the first time when we bred this. This was the first time it had ever been bred in captivity. And all these single large polyp stony corals are actually collected from the reef. They can't be asexually fragmented like a lot of other stony corals. And so you're always going to have an impact on the natural community there. They're rarer in general, but then obviously they drive quite a high price. So if you spawn these ones as well as your acropories and your major reef building corals, again, you've got another avenue to generate funds and money to actually push back into that restoration program. So this circular economic aspect, I mean, in this context, is either with the urchins or with the high value coral, where you can be pushing 30% of those products into a business model and 70% going into a conservation program. Yeah? You can faff around with your percentages depending on where you are, and this is available to everybody anywhere they want. And we don't want to make those businesses. I haven't got time for those sort of things, but I want to generate alternative livelihoods, different options to usually people in the countries that maybe be doing those coral farming already, to give them these other alternatives and options. And this is exactly what we're doing with a CORDAP grant, where we're looking at things like Trachophilia and button scollies, working in Indonesia to generate the blueprint and the model for this circular economic concept. So we work with the government over there, we work with researchers out there, and we work with the coral farmers. So it's not about taking livelihoods from people, it's about giving massive opportunities back and hopefully saving the world whilst you're doing so. So you make money and conserve the reefs all in the same shot. So our mission to spawn and grow corals at industry scale, year-round, and meeting necessary demands for restoration and research purposes, started off as a fantasy and became reality quite quickly. There were other things along the way, so completing the life cycle of broadcast spawning corals. We did 50 species so far, so we're not just one-hit wonders with the acroporids, like some people think. We've done a whole heap of different species, and this all feeds into various different ways of where that restoration can really take off. But what's the problem with that? What's the problem? Scale? You're all tired now already. Should have got you to stand up. Pardon? Initial investment, yep. So initial investment, this is where the business comes in. So I'm glad you said that. Initial investment, because we run the business. Just two of us at the moment, with myself and Jamie, my PhD student, we can set the profit margin. So what we can do is, if it's a charity from a developing country, we can do it at cost price. And this is what we're doing. So where possible, and CORDAP was one of these ideas, is you have to run it at cost price, and it's more than feasible if we can do that. We don't need this business to generate money, but then there's also philanthropists out there, and a lot of philanthropists out there, and a lot of people willing and hoping to do their bit. And we've found, particularly in the Cayman Islands, for example, we had a family who bought these systems for the Cayman government, and then we went out and taught them how to do it. So there's a lot of different routes to doing this. And I don't think finance is a major hurdle, and we work with people to either find grant money, to give them the quotes or whatever's necessary, but then also we put in funding bids, obviously, as well, to try and get this across. But to me, scale was always something that people asked a lot about, and it was what we then put our next challenge on from the Coral Spawning Lab. And this was a concept piece that we designed for a client, which will remain nameless because we're not allowed to say it yet. But it's more than a concept, but it generates a large amount of those corals we're talking about, and it's also mobile and off-grid. So you've got the solar panels you can see on top, which gives it about 70% on a good day of the energy demands it needs. And then obviously you need a little bit of extra energy to push that through. But these are two 40-foot containers, but it all started actually with Oldenburg University in Germany, where we built the first lab in a box, we call it, where we put systems. You can put between 2 to 4 systems into these lab in a boxes, so that gives you 2 to 4 spawnings a year, depending on what else you want to add into that, quarantine systems, all these different things. And it's fully contained with slave doors and air conditioning and so on and so forth, RO units. And the two 40-foot containers are basically just larger scales of that, but it really starts to give you an idea of the scale that you can talk about in this mobile approach. So if we think about scale again, and this was a study we did with James Pfeiffer and Laurie Raimundo in Guam, and we were looking at high flow environments, and that corals in high flow environments often were found to beat the heat. So it made us think, right, we need to make something which can harden our corals again a little bit more. So we made these V-shaped raceways. So these are a novel design again, which are based on aquaculture in general. And the V-shape is quite good because it's modular in one context, so you can buy little individual bits and then start to pile it all on together to make large tracks. But the key is that V shape, which means sediment all falls to the bottom, and it makes easy cleaning process as well. And then we developed these rack systems as well, where you can put your settlement media, your settlement plugs, and you can actually lift those racks up and dive with them and push them out onto wherever you want to go to. From the scale side of things, this is just about a 2 meter by 2 meter 4-shaped raceway, and it fits about 8,600, no, not about, exactly 8,640 plugs. What you get, so this is in the 2 meter by 2 meter space, what you get is usually about 5 spats per plug, and so if you microfragment up that plug, you can actually get upwards of 43,200 corals from a single unit. Is that enough? No, come on, work with me here. This is hard work. No. Say it loudly. No, no, we want more. So if you do that modular unit and you have a 24-span V-shaped raceway, footprint of 15 by 6 meters, we have a holding capacity of 51,840 plugs. Is that enough? No, no, carry on. So Sony Avo, and I got permission to share their name of them, which was good, commissioned this. So this was the largest raceway system we built, and I would argue they've probably got one of the best capabilities to do large-scale restoration at the current moment, because this is only one part of the things that they're doing. But it offers a large amount of opportunity. And come on, move on to the next one. How do we move on to the next one? Stop. Any help? There we go. Nope, that's back. So this has been commissioned, like I said, it's in Sony Avo now, and it's doing its job. So on top of that, you need to think a little bit more. So Ivan Kano gave a talk about heterotrophic feeding, and there's a few other people who have also highlighted this, and you really are what you eat. And so when we explore the feeding of the larvae as well as the adults, you can start to see some differences. We were a victim of our success with the survival curve because we actually created too many spats in this instance, and so survivorship was not that good actually, and that's been shown as well. But what we were able to show was that in the fed, so this is Tysochrysis, and then rotifers as well were quite good, and then Benipeps was an off-the-market food. But with Tysochrysis, we showed that you got an increase in Symbididaceae density, an increase in total chlorophyll, and more importantly, you've got significant increases in that transition time from healthy to first signs of bleaching when we put them through a thermostress experiment. So that feeding aspect, it doesn't stop them from bleaching in any way, shape or form, but it gives them that bit of respite. So it's another thing which adds to shifting and changing that. We were out in Cayman, and we were doing a workshop on our ex situ spawning, and we wanted to go and get some in situ spawning at the same time as well. And that was fun and exciting at night, exhausting when you're doing spawning during the day and spawning during at night. And we decided that we can actually make something a bit better. With a little look, we found this Suzuki paper, which highlighted a concept of developing a special bundle collection system for collecting stuff. We redesigned that and re-engineered it in quite a different concept, and we built this aspect which allows you to do exactly that. And it's a blend of science that was already published, new technology that we bring to the table, combining things like restoration projects like the Mars sea stars, for example, which are used throughout the world, and then oyster and mussel farm technology, where you're dropping those settlement media into this enclosed environment and getting hundreds and thousands of in situ reared larvae also settling. We then recommend that you take that onto the reef, off the reef, to increase your protection and your survivorship of those corals as you move forward. But once you've kept them in an ex situ nursery, again, those V-shaped raceways are perfect for that. We've also shown in Palau with James Guest and Adriana that if you have a stage of in situ nursery, the survivorship and growth of your corals is also significantly increased. So these corals are all the same age. These are 2.5 years after spawning. And the ones were put like 5 months ex situ and then put out onto the reef on the left-hand side, 11 months and then put out onto the natal reef, so doing quite well, but 13 months and still in an in situ sheltered nursery, and it was a very simple design nursery just with stuff we found in a local hardware store, and you can see that growth was massive. These corals actually spawned in the next half a year, so when they were 3 years old, and what we've since shown is that, with the paper in review, is that you can actually pass on that thermotolerance as well. So if you know the thermotolerance from the adults again, you can pass that on to your juveniles and to your offspring, and then that passes on to their offspring as well, which is hopefully a groundbreaking study. So I'm going to whistle through the next stage. I think I've probably got 5 minutes still, I'll say. 2 minutes. Oh. So this is where you push them out onto the reef after that. So obviously there's a whole heap of different designs and different structures which are available to do this. And you can build this pipeline now. So you can have this pipeline where you have ex situ spawning capabilities. You have in situ gamete collection as well as the phase shift structures. You've then got ex situ settlement and in situ embryosis and settlement, and then ex situ grow out. But then also we want to build these low-tech solutions and start making sure that people can, in any country, in anywhere in the world, can use the same technology and the same style, but with much cheaper budget. So this, again, hopefully circumvents a little bit about that initial investment. So if you want all the bells and whistles and all the automation on your phone and things like that, then obviously that comes at a cost. But we strongly believe, and we haven't done this yet, that we can do certain parts of the process in a much cheaper way. Unfortunately, this project didn't get funded, but we're not going to give up on that one, and we're still going to push it out. And if anybody wants to talk about that, please give me a shout. So, Sergio highlighted in his talk that you need to adapt your plans to the local needs and give the power to the people, and that's exactly what we do. So is that enough? No. In the last 30 seconds, I'm going to cover another part of what I wanted to highlight, and this was probiotics. So many of you will know this is Raquel from KAUST, and the application of probiotics is something we've been working on for quite a while, but the way we use it, or the way we're applying it at the moment, is to reduce that need for CCA. So Kathy highlighted in her talk that CCA is bad in many instances, and there's a lot we don't understand about CCA, but if we can remove that need, then that's going to increase the settlement and survivorship. People use what they call sort of fairy dust, crunching up CCA and dusting it over, and we do that as well, and it works very well. But we also wanted to look at a little bit more in depth into the microbiome side of things and that potential of probiotics or prebiotics, where you actually inoculate strains of bacteria onto the plugs, increasing settlement and also increasing growth. We tested 21 different strains of Pseudoaltomonas, and we showed that one strain, SMS1, actually increased growth pretty significantly, so only about 3.25 and 4.4% increase in settlement. We did the trial twice just to make sure we were right, and survival increased about 21.1% compared to the controls, which were with the fairy dust. But we also found another of the microbes doubled the growth, so didn't increase survivorship, but doubled the growth. And we interestingly found one microbe which actually eliminated settlement. So that was obviously not good for our practices, but could be used as an anti-biofouling tool moving forward. I'm not going to tell you much about probiotics because there's been a few talks about that, but this is where we need to move into, or this is one area where we're pushing, and this is the insights into cultural bacterial fractions. So this is trying to pull out all the different microbes which are available to you to use for that purpose itself. And in a lockdown project, we found out of 52 studies, there are 3,055 isolates which were available or are available to different people. But in a single study just after that in 2022, we showed just with Posilopera that you could, and with one media, you could actually isolate 395 separate isolates, which represented 154 species. And all these were sequenced for their genomes, giving you a large amount of extra information. So the proof of concept study was published here. You can have a look at that. And it really showed that probiotics does actually work quite significantly. And we showed that it was linked to heat stress. So we called it the post-heat stress disorder, where you eliminate or you reduce the chance of that necrotic aspect or the apoptotic part of the process. And again, it's giving them a little bit of respite. But there's more work focused on how that actually starts to be pushed together. And now people are looking into delivery and a political process about why you should do it, how you should do it. Is it the best option? Is it better than the use of antibiotics, for example, for treating corals on reefs? I would argue yes. And it's all along the lines of when do you actually act? So we talked about the sort of cost of inaction associated with this. And game theory suggests that you need 40% of knowledge to actually act. And I would say we have that information, so we really need to push forward as we move forward. So the last few things I just wanted to show you and highlight are 3 other projects that we've been heavily involved in. This was Genomes for All, so this was the Aquatic Symbiosis Genome Project, and it was funded by the Gordon and Betty Moore Foundation with the Sango Wellcome Trust. And we sequenced, or we've received 90 different coral species from all around the world. We're processing them slowly. It's a bit of a longer process than I would have hoped, but these are the genomes which are now publicly available. We're still writing the genome notes, and hopefully these are correct. And don't worry, Andrew Baird and Tom Bridges are on our team, so we should get it right at some point. Over to you guys. And then a new model. This is Chris. I'm not suggesting that Chris is the new model. What I'm suggesting is Galaxia is a really cool new model. So we've been working with Maren specifically and her team to sort of champion the use of Galaxia fascicularis as a key model organism to give us reef building folks that true model, get rid of the hydras and aptasias, they're rubbish, and we'll start working with Galaxia. I don't mean that, sorry, hydra and aptasia people. But you can adapt them, you can change them, you can spawn them, you can bleach them, you can reinfect them, and we've published quite a few papers on that topic, so please have a look or have a chat with Maren specifically about where that moves forward. Penultimately, I wanted to show you or highlight a talk that Triona is giving in session 13. And this is a really cool project we did, which again shows that power between working with business, science, and chemists in this instance, because reef relief is a concept which was designed by an advertising company called McCann, and they said, why not build a reef positive sun cream which is beneficial? They contacted me and I said, bullshit, that's not going to work. I'll call that and I'll test that for you. And I really didn't think it was going to work at all, and I thought we were going to find the least worst sunscreen at best, and hopefully put something better onto the market. I was staggered by what we found, and Triona's going to go into the details of that, but here you can see an example of our control systems where they grew, so they're good. A reef-safe sunscreen which you get off the market was reef-safe. Didn't kill the corals, but reduced the growth. But Reef Relief itself significantly increased the growth. So we saw a significant increase compared to controls of upwards of 21%. In horizontal growth, vertical growth was 5%. There wasn't much change in the wet weight. But you compare that against the sunscreen, then the numbers increased quite significantly. I purposely didn't put in the science there because please go and see Triona. She told me not to say that, but please do go and see that because it will be great for your advice. It's fully certified. It's actually ready, market ready, FDA approved, various other certifications, and we even won an award in the recent Cannes Lions Festival for product innovation. And that powerhouse between a marketing company, a chemist, and scientists mean that hopefully you can trust this, and it does actually really work. On top of that, the actual packaging is 100% recyclable. It's got a negative carbon footprint. This I'm not 100% sure on, but it's made from sugarcane resin, so in theory it sequesters carbon as you're walking around or sat on the beach. So well done, you guys. So finance, I don't think, is a problem. So there's a lot of money out there, and when I was at COP, that was what they were saying. It was historically an issue, but money is there, and money is available to use, and it depends on how you use that money. So we generate money through the business, and we have the ability to shift and change where that money goes. What I do personally with the profit from a business is I buy land in the UK. So we have about 37 acres of land we bought over the last few years. I plant trees. We've had about 3,000 trees planted, and I've built about 3 lakes on this land. And that's my method of reducing my carbon footprint when I come to places like this and drink out of cups and fly and go to conferences to tackle my own carbon footprint, which I recognize is significant, and also that of the companies because we're shipping containers around the world. So individuals can make a massive difference, and then we do all the little other bits as well, like fighting policy and so on and so forth to make a change. So my lasting points to you guys, if I can, is listen and learn from lived experience. So there's a lot of people outside of the academic sphere who have better ideas than us sooty academics. So co-create with multiple people. Everybody talks about this, but I don't see a huge amount of co-creation. I have seen quite a few good talks, specifically from a great Italian group who have done some fascinating co-creation and showcase that work. Once isn't enough. You need to keep on inventing, keep on designing, keep on pushing boundaries. And to that degree, we've just, in November, we set ourselves a challenge to flower seagrass ex situ, because no one had done that before, on demand. And we were like, yeah, we could do that. And about a week before we came out here, we had Zostera noltei and Zostera marina start flowering. And my PhD just texted me the other day saying that the whole bed is now flowering, which is pretty special. So we're hoping for seeds in the next few weeks. And this will be another world first or 2 world firsts in that instance. So defy perfection paralysis as well, and this is the cost of inaction, and this was something I had to overcome. I wanted to be 100% sure that what I was doing was the right method. But if you think about that game theory aspect, about 40% sure, it changes quite a lot of things. So this is a major thing that I would encourage you guys to push forward on. That doesn't mean you go gung-ho. You need to have that science to understand what you're doing, but it allows you to move forward. And importantly, don't get left behind. If you are panicking about sharing information and pushing out and not talking about ideas and concepts, someone else is going to do it probably quicker and sooner than you. And ideally, we all work together. We've got 6 years possibly to save reefs. We've got 12 years possibly to change our carbon footprint. And we have to change our actions if we have any hope of changing actions of others. So we have the solutions, we have the steps we need to take to fight climate change and restore our reefs. So all we really need to do and left to achieve is wake up and change. So with that, I want to thank the team. I've had a fantastic team, and it's continually growing, and all this work is on their shoulders, and all my collaborators as well. And so I'd like to say thank you, and hopefully field some quick questions before you go for your coffee break.
Thank you so much, Mike, for that very inspiring presentation. We have just a couple of minutes of time for questions, because we are a bit running out of time.
Sorry.
But please. Here.
Hi, thank you for the mention, first of all. I wish to ask if you observed in the coral co-culturing with sea urchins any types of predation by this species on the coral you maintain, or erosion, or any threat to the coral by this species.
From the urchins?
Yeah.
No, we get the accident. I think we get accidental damage. But the benefit far outweighs any negative we've seen. So we haven't actually been able to record any proper negative, but I have seen, depending on the size as well, we've sometimes tried to speed things up a little bit and put some slightly medium-sized urchins in, and then we find that they will probably accidentally graze them. I say accidentally, we don't know if they eat them, but I don't think they intend to.
Hello. Hi. Oh.
Sorry.
Hi, thank you for the great talk. You mentioned the importance of circular economy for and supplying the marine fish keeping trade. However, what happens when this demand is saturated, and are we anywhere close to that point?
As in, you think that people won't want that stuff?
Yes, supply beyond a point is not going to be.
You'll be surprised how shit people are at keeping corals in aquarium. They quite often die quite large amounts, and so there's $1 billion trade at the moment, and it's been driving corals from the wild always. And so what we're suggesting is that you flip and change that a little bit. So we push these into Fiji and Indonesia and even Australia and do large-scale production, and then still ship them out along those sort of lines. So America is one of the biggest trades for the aquarium. Europe has quite a big one as well. And we work with the large-scale industrial traders as well. Quite a lot of them, and not all of them, but quite a lot of them have good ethics as well, about that they don't want to, what we initially thought is we would build large-scale labs in the countries which want them, so in Europe and in America and stuff like that. But then with discussion, we found quite clearly that they don't want to do that because they don't want to be seen as the bad guys again, taking the jobs from Indonesian coral farmers and things like that. So they're very supportive and also pushing some finance into the fact that we can train and get these people to that point. And they will also guarantee, to a degree, purchasing coral or fish at that price.
Thank you.
Hi, Mike. Thank you for your great talk. Yeah, it was inspiring. I would like just to add something that maybe was a concept that maybe it was not allied. Sorry, guys, I am kind of a material scientist. I am not a marine biologist, so if I say something that is wrong, I'm sorry. I think what was missing in this talk regarding the impact and environment and everything was the concept of sustainability. That most of the time is not connected with the, something natural, like you said, oh, the packaging is natural, everything is natural. But as we have here a lot of garbage, maybe they are made of polymers that are called like PLA or polylactic acid and whatever. That actually to produce them, we are consuming so much water that in the end, if we use common plastic and we can recycle, it can be even better because we are in way saving water, saving and consuming energy and so on. So the concept I would like to highlight is that when you speak about these things, we need not only to think about the CO2 emission and whatever, but is the concept of sustainability is something larger. So this means, okay, we are using something, how we are impacting the environment right now and what we will do in the future. So all the materials that you're using, whatever you are using, should be considered in a larger scale.
Yep.
And I think what you have done is great. I really appreciate, and I think it's for everyone an important step for the future work in coral reef. But please, let's keep the sustainability in mind. So this means let's try to see if the things are good or not, and if they are working. Maybe it's okay just because they are working and we need to go further somehow. I'm thinking about like natural things and whatever, but maybe there are other things that are already working and there is no reason. As other things like epoxy resin and whatever that maybe you're using a lot can be replaced with something more, let's say, eco-friendly or sustainable. This is what I would say.
100%, and this is the co-creation side of things. So to take Chris Volstra's talk, and he said we need to do good things better. We can always do good things better. We do good things here at the conference, but we can do better. And with all these concepts, they're always developing and they're always changing and they're always adapting. If a business doesn't change, so if you think about it from a business point of view, if a business doesn't change, it flatlines and goes out. So you always need to be continually thinking about changing things, and we are open as a scientist for large-scale collaborations and to learn from also mistakes as well. So we don't get everything perfect, obviously, all the time, and that's when we realized, obviously, the cost of these systems to actually produce was an inhibition right from the onset, and so we started working towards a way of being able to create that on-site with local solutions, with concrete or with bamboo or with whatever you can find, hopefully in a sustainable manner as well. And then that won't be the end of the story. You'll then carry on and try and find something better again. And this is where this is the big call to the community, is that we have a lot of things that we know and we need to start doing more. And don't necessarily wait for that perfection side of things before you do, but don't be afraid to change it when something better comes along. Thank you.
Good job. Thank you so much, Mike. So just a couple of technical notes before the coffee break. Please remove the poster by the morning. And if someone needs transport to the airport around the noon, please go to the reception. They are arranging something for you. Okay? Enjoy the coffee break.